Look at this, like you can see I have a 160 megahertz. I am doing some speed test with my Pixel phone. So now what do you think about, in this particular kind of situation, if a 20 megahertz or narrowband interferences come? Now before Wi-Fi 7, you have to sacrifice lot of channel, because now if interference come, one of this particular example, now here one channel number 5 and channel number here being interfered, so then all the secondary channel they cannot use. So that way either you have to go to like a 20 or 40 megahertz communication, almost you are losing 2 or 4 channels depending on the where the interference hit. So now with Wi-Fi 7, this is being addressed in a feature called Preamble Puncturing. So let me show you how that works. So now you can see here, now I am doing the download test again. So now this particular time I will bring interference and you will see, so that one particular channel being now in here, you can see this channel basically being punctured. Okay, so channel number like a 17 being punctured, so rest of the 140 megahertz being used. So now in this particular post, let's go and understand how this preamble puncturing feature work. I'm using a Cisco 9800. Let's go into detail how you configure it. Let's go and have a look a little bit of a theory part. So now this is like what happened with pre Wi-Fi 6. Like Wi-Fi 6 introduced this concept of preamble puncturing, but not many vendors implemented. So now prior to preamble puncturing, depending on the interference comes, you can see like this like 80 megahertz kind of communication. Mostly you will basically wasting 2 channels. So you can only go to 20 or 40 megahertz if a 20 megahertz channel being interfered. So now with Wi-Fi 7, like EHT, so this is supported OFDMA and non-OFDMA communication, but mostly valuable in like a non-OFDMA kind of communication where you can use a large channel, and then if a interfered come on a 120 megahertz or 40 megahertz, you can puncture that channel and rest of the channel can be used. Now with preamble puncturing, as you saw in the particular video earlier, spectrum analysis, you saw only 20 megahertz being punctured, rest of the channel being used. Now this is like exactly what we demonstrated in this particular example, channel number 9 being punctured. So now there are few rules to remember. Now it has to be, channel width has to be 80 megahertz or higher. Okay, that's the first condition. And then the other thing is only secondary channel can be punctured. That means this interference need to come on a secondary channel. So you cannot puncture the primary channel. And once the puncturing has been implemented, so now this information will be advertised in a beacon frame and certain other frames as well. And in the preamble itself, this information goes in the universal signaling kind of field. So now let's look at 80 megahertz kind of communication. So if a channel being punctured, like you can see, you can puncture a 20 megahertz channel, and then that information will be updated in the EHT's kind of universal SIG field. If a value number 1 mean first 20 megahertz being punctured. If a value 2 mean second 20 megahertz is punctured. So in that scenario, it cannot be the primary channel. So your primary channel has to be some other channel. So now like there are 4 possibilities. So these are the 4 scenarios there. Now if you are using a 80 megahertz 160 megahertz communication, so you can puncture 20 megahertz channel, or you can puncture 40 megahertz channel. So if it is like a 20 megahertz channel, depending on where's the punctured channel, so the punctured channel information field value will be 1 to 8 If it is 1 mean first 20 megahertz being punctured, 8 mean last 20 megahertz being punctured. So now in this particular scenario, they are allowed up to 2 channels. Continuous channel can be punctured. That means 40 megahertz. You can puncture out. So now in that particular scenario, you will have a 4 different possible scenario. The value being basically advertised from 9 to 12. If 9 mean first 220 megahertz being punctured, 10 mean second 20 megahertz channel being punctured, like that. So now in this example, you can see a 40 megahertz being punctured here. Now if it is a 320 megahertz scenario, so you have a minimum size of puncturing is a 40 megahertz. Okay, in that way now in here, what I'm representing is a 220 megahertz channel. So that's what channel numbers here. This one block representing a 220 megahertz. In that way, minimum you can puncture at 40 megahertz, and value being 0 to 8 in that scenario, and 11 to 9 to 12 will become if you are puncturing 80 megahertz channel. So now this is a 80 megahertz punctured. Now in this particular scenario, they are allowed up to 120 megahertz being punctured. That means 80 plus 40. So that way now whenever you do that, so that values being number 13 to 24 defined, depending on first to 80 megahertz you can puncture, and some other sort of 40 megahertz, or the last 80 megahertz can be punctured. You can use depending on the second 40 megahertz, these numbers will be defined. So those are the sort of defined values. So now let's go and have a look in the 9800 how this is working. So here is my 9800. Now if I go to configuration and RF profile, so you can configure preamble puncturing in 5 gigahertz and 6 gigahertz. So now if I show you my RF profile, 6 gigahertz, now under 11BE, you can enable or disable preamble puncturing feature. Now what I have done is basically I have enabled this feature across both band, but now just illustration point of view, I have a access point now configured for at the moment it is configured for 160 megahertz. Now 5 gigahertz has been disabled. I want to plan to be connected 160. In that way it is easy for me to represent rather than MLO kind of complexity. I just basically my advertising SSID on 6 gigahertz. So now as I showed you earlier, now let me just do a speed test here. So right now no puncturing has been enabled. So in that way you can see my pixel when I do a speed test, it communicate across all 8 channel. Okay. So now in 6 gigahertz I don't have any interfering sources just to inject the interference in particular sort of channel. So now if you have a 9800 controller, now you can see a different CLI command is available where you can puncture a particular channel. So now if you go to a 6 gigahertz is slot number 3. Now if you specify, you can puncture any given particular channel. Okay. So now that way what we're going to do is probably we'll enable the packet capture, and then we'll go ahead and puncture. Probably let's puncture the channel number 13. Okay. Now whenever you specify channel number 13, so you can specify whether you want to puncture 20 megahertz, 40 megahertz, or 80 megahertz, or 80 plus 40. Okay. But sometime 20 megahertz can be punctured in any bandwidth channel like 80, 160, 320, but 40 can be punctured 160 or 320. So 80 can be punctured only in 320 kind of scenario. That way these two applicable for 320 megahertz. So now we will basically not immediately go and hit this button. What we'll do is basically we'll puncture that channel, and then while taking a packet capture, then we can able to understand that. In that way now what I'm going to do is, so I will I have my Meraki access point set up in the same sort of a spectrum channel. In that way, I can go ahead and take a packet capture from the Meraki side. So now in here, I'm taking a packet capture. Probably let's take a 120 worth of packet capture. And in here, let's say Meraki capture. Now, let's say this is 9800 preamble puncture. So I am puncturing 20 megahertz. My channel width is 160 scenario, 160 megahertz scenario. Let's say take it 1. Okay. Probably, like I will go ahead and take another capture on my WLAN as well. So sometime in here, 6 gigahertz, channel number 5, 160 megahertz. So let's start capture on both scenario. So I am capturing now. So now what I'm going to do is, while capturing is going on, I will hit this channel number 13 puncturing. Okay. Now 13 being punctured. So let's see whether we can see that in the spectrum. Now let me just not a speed test. I will just generate some other traffic. In that way, my Meraki capture will not basically, like timed out. Let's see. Hopefully I will. So you can see now it's not, traffic is not that huge, but still you can see this is being punctured. Okay, channel number 13 being punctured here. So you can see capture has been stopped. So I will stop this capture too. And this one as well, I will save. So now spectrum point of view, just to make sure that channel capture, let me just go ahead and do a speed test and generate a significant amount of traffic. Now I'm doing a speed test. You can see here. Now you can see when speed test generated, you can see channel number 13 being punctured. Okay. Even the previous scenario as well, I'm expecting that information being going on. Now you can see upload traffic is going on. Still it is being punctured, channel number 13. So if I remove that puncturing, now let's say basically I want to puncture channel number maybe 23 or 24, 25. So not that particular channel I want to. So now you cannot puncture 2 channels. It will be only 120 megahertz can be punctured. Okay. So now I punctured that and I'll do the traffic here. Now you can see channel number 25 being punctured. Now if I clear this puncturing, when the traffic is, now you can see all channel being used. Okay. So that's the idea. In that way, dynamically, even the real world, if interference come, AP should be able to dynamically puncture that channel, and when the interference go away, they should be able to use. But in this particular testing, I can only do the static puncturing because it is in the controller configuration point of view. I can puncture that channel statically. So now let's go ahead and have a quick look of the packet captures we took and see whether we can understand this behavior. So now what we have is, like these two captured. I would basically this AR tool capture as well. I will rename. In that way, I can give these both captures. At least in that way, you have a capture with you. So I will say this is 9800 preamble puncture. So we punctured 20 megahertz in the 160 megahertz scenario. So I will keep its AR tool, and this one is taken from the Meraki. Now if I open this, let me just open Meraki capture first. Now in here, So now if you want to look at the beacon frames, example, now you can see now the MRN, if you look at the beacon frame, there will be channel number 5 is the one you need to pay attention, because Meraki has different other channel it's being captured. That way, beacon frame point of view, if you filter the beacon, look for channel number 5 beacon frame. Okay, you can see any of this particular beacon frame. If you look at the EHT operations, like EHT capability, EHT operation, so this operation element will indicate. Now, if I look at the operation parameter, now initially you can see there are no preamble punctured information, because we punctured this towards middle of this particular capture. Okay, in the initial kind of beacon. Now if I want to filter for this channel, we can filter for this channel as well. Let's do that. In that way, channel 5, apply current filter and select it. Now this will be the initial. Now here as well you will see the Meraki SSID being captured. If you pay attention for simple MRN, that's what the 9800 SSIDs. Now initially it is not being punctured. You can see that information is not in the EHT operation element. So you can see there are no punctured. But now if I go towards end of this kind of capture, let's see in somewhere here. EHT operation element. So now you can see it's indicating disable subchannel bitmap. That means this is saying, value being number 8. Okay. That means now in here, if you look at the operation parameter, it says disable subchannel bitmap present. So now the bitmap value being number 8. Okay. Okay, so now let's look at the data frame. Now in the data frame, if you want to find out, a frame have a U-SIG value. Now, if you look at here, you can see, a lot of this frame, if you go to radio tap header, you see the U-SIG value. And the U-SIG value, if you expand in this one, now let's go ahead and check here, sometime. Let me explain the MPPDU. This is where, puncture channel information. I want to see. So this is initially there are not punctured the channel, okay, but towards initially we didn't punctured. I'm just checking. Now you can see here, initially we punctured channel number 13, okay. So that tallied here, you can see we punctured channel number 13, mean in here value should be 1, 2, 3, 4, value 4. That's what we see here. We can see channel number puncture channel information is 4. Okay, so now that is, now if I apply this as a column, let's see whether we can get that value. So you can see puncture channel information. You can see pretty much 4. So now that's the static puncturing. I think when we take the packet capture, you can see, it was pretty much punctured. Initially we didn't puncture, but then we punctured channel number 13. Okay, so value being number 4. So that way you can see here definitely, punctured being used, number 4. So now, depending on the channel width and the punctured channel, so now this information, let me just now find out the first frame where this information being now in this, I will remove the filter. Now filter with the 3909. So now what I want to look is, just before that kind of 3909. What kind of now in here, this is a beacon frame. Now this is sort of a MRN. This is sort of my beacon frame here. So I would like to EHT operation element and see what it shows about. Now, okay. So now this bitmap value here, it says hex value is 8. Okay, it's like a 4-bit value. Now if I look at another beacon frame after that 3909, we can check whether any difference there. This one here. EHT operation. Yeah, so this value, like in here, it's like a hex value 8. So now there may be subtle differences. Now what I'm showing here is, this is like punctual information in the U-SIG field value. Now if let me just quickly say disable, copy this, copy field name. I will go and search on the sort of a below standard. Let's see whether we can quickly find it out together. If not, probably. In order to understand the bitmap value, so now if I search that disable bitmap, subchannel bitmap, you can see it's basically talk about now which channel to be punctured. Okay, now in here, if we look at now in our scenario, how we need to understand is, probably let me just highlight in here. So now in our scenario, if we look at, so now in the beacon frame, let me go back. Now you can see the disable channel bitmap is appear like a hex value 8. Now if I go back to hex value 8, so now in our scenario, it says disable subchannel bitmap value is 8. Now in hex, if you basically converting 8 into binary, so this will be 0001 and 0 to the power 0 to the power 1 to the power 2 to the power 3. So now it will be like here, 4 zeros and 1 0. Now once you convert to binary, now what's this standard says, if I go back to again, now what it says is, each successive bit in the bitmap correspond to the next higher frequency of a 20 megahertz subchannel. That means in here, now this is, if it is this bit is set to 1, that means first 20 megahertz being punctured. Now this is basically second, third and fourth 20 megahertz. Now if we look at the sort of a slide, now this is the same scenario here, in that way, fourth channel being punctured. That means the channel 13, okay, channel 13, 15913 being punctured. So in that way, disable bitmap channel value will be hex value 8, that indicating this channel being fourth channel being punctured. Now I hope you get the idea here, in that way, when you look at the puncturing, you can check in the universal SIG field value. So now in this particular capture, we check that as well. In that way, now we are looking at the same information here. Now, even if I go to the AR tool capture, this should be available there as well. When we begin with the capture, let me just make sure it is being captured there as well. Now initially, channel being not punctured in the EHT operation. So there are no punctured channel information. But if I go towards end of this beacon here, now if I go to the EHT operation information, so you can see subchannel bitmap. So bitmap 8 means you need to convert this to binary and find it out. So now, so binary, like in here, the 8, when you convert into binary, 0, 0, 0, 1, 0, 0. Okay, that means like a first, second, third, and fourth channel being punctured. So that's how you need to interpret this value. So channel 13 being punctured. Now in the data frame as well in here, you should be able to see the sort of, if I filtered from U-SIG field, now you should be see, now I already add the column there. So you can see the puncture channel information value will be 4. Okay, that way that's a, like again, if I show you the slide here, so we saw that field information decoded basically 1 mean first channel being punctured, 4 mean fourth channel being punctured. Okay, that's in the U-SIG field. That's information there, or even the beacon, association response, those kind of information. If a client connecting the wants the punctured, association response frame should be also including that detail. So I hope you got the idea. Like that way, it's a very essential feature if you using a large bandwidth communication. If you can dynamically puncture when the interference come and using the rest of the channel, this is a very useful feature. So I hope it's useful. Until I see you in another video, take care.